Hello, everyone. We are both having varying degrees of technical difficulties over here, so uh, we are scrambling a bit.
No, we are adapting.
We are adapting and
Yeah.
overcoming.
Yeah, overcoming. Exactly. Um, uh,
And I'm still fighting this cough. So I've tried to time my medications so that I mostly have a brain and mostly don't have a cough. And I'm really hoping I didn't screw up in either direction.
okay, I'm good.
All right, I'm looking for my recording software. There it is.
I'm looking for my YouTube software.
Um,
Okay.
all right.
So we watched a good movie last night, which I have had never seen.
What was
Uh,
it?
it was The Wild Robot.
I've heard good things about
It's
that.
it's really good. Yeah. Yeah. It's on Prime
Uh huh.
and it was yeah, it was just great. Like very funny. The writing was pretty well done, for a kids movie.
Yeah.
But with like it was a kids movie, but there was a lot of murder.
Really?
Yeah. Yeah. So I mean there was a lot of death and and animals killing animals or trying to kill animals and so I thought they did it they tackled what can be a very challenging, like, how do you tell a story about animals all just
Yeah.
getting along when the reality is that the predators starve, right? If everyone gets along, the predators starve. So and so I thought they did a pretty good job on the on that. So yeah. Okay. Yeah, we're still messing with our lighting. I'm still messing with my lighting,
Yeah.
so pay no attention. I'm like so I did my Australia stream last night,
Uh huh.
and so that goes from 10 till midnight on
Oh.
Sunday night.
Uh
And the
huh.
problem is that whenever I do a live stream, I'm zazzed,
Yeah.
right? Like
Yeah.
it's
And then you
the
can't go straight to
and
sleep.
then I can't go straight to sleep. And so I didn't get to sleep until 2. And
Oh,
normally I'm in bed
jeez.
and asleep by 10. So this is 4 hours. And then but then my brain
Oh.
always wakes up at 6.
Oh,
So
jeez.
yeah, yeah, yeah. So I'm like waking up at 6. And so I'm on like 4 hours of sleep. So I am like, this is the last big responsibility that I have for the day. And then I'm just going to go nap for a few
Yeah.
hours
I
to,
I am I'm fighting this stupid unending cough,
yeah,
and so sleeping through the night has been a challenge.
yeah.
But yeah.
Yeah. Yeah, yeah. So I've become such a creature of habit that to do this, what would have been 10 years ago, like, like, oh yeah,
No
stay
big
up till
deal.
2 in the morning, no big
Yeah.
deal. Play video games, whatever. You get lost in the moment, you know, go to the bar with friends, whatever. Now, no, Grandpa Fraser needs to get to bed before 10 o'clock, or else he's like, whatever time I go to bed, then it's a countdown to that time that I get up at 6 o'clock or even
Oh
earlier.
man.
And even like my brain, like I'm the older people in this audience will know exactly what I'm talking about. I'm not sure sort of where you're at um, on that scale yet, or maybe it's just a man thing, but I don't know because like I just, when I was younger, you went to bed and you got a good night's sleep and then you woke up, and
Yeah.
now like I just sleep less and less. And I know a lack of sleep is really bad for you. And so I have to improve my exercise, improve my diet,
Yeah.
improve my sleep hygiene to just get better and better and better to compensate for what is this sort of increasing sort of sleep
Rebellion.
deprivation. Yeah,
Yeah.
rebellion by my body about getting
Yeah.
enough sleep. And I think there's, the one path is to say, no, just like old people don't need to sleep as much. That's just the way it is. You're young, you got to sleep. But no, I don't think so. I think you need your sleep, and it's just that your body is, you're getting old and your body's breaking down. And this one of the ways that it breaks down is it no longer is good at managing your sleep schedule, and so you've got to be on it, and it tolerates no mess ups. So anyway, this is my. I don't know what the solution is, because I really enjoy doing that late night stream, and I enjoy being
Yeah.
able to provide that content to a hemisphere of the world. And at the same time, I've got to figure out a way. Like, I'm going to block out the next morning, so because I had to get up. Partly, I think I had responsibilities this morning. I had to do an interview at like 8 o'clock in the morning, so I was like,
Oh,
okay,
oh,
I
geez.
got to get up. So I think I got to block out the next day and go like, nope, nothing. Like, I know that I'm going to need to sleep in. I'm going to need to nap or whatever. So anyway, enough about my body falling apart as I enter my senescence. Let's get into this week's episode.
Okay. I am pressing record on my audio. I am pressing record on my video. We
Okay.
are recording.
Okay, excellent. Here we go. Astronomy Cast, episode 756, Dust Storms. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well enough. I'm still fighting a cough, so I apologize in advance if there's
Right.
any coughing in this episode. It's just from allergies, so
Yep.
no real worries, just frustrations.
I'm sure there will be this beautiful edited version that no one hears the coughs. But it's for you, I know this is sort of like a response to smelling tomatoes or something
It
ridiculous
was
like
the
that.
most ridiculous allergic
Yeah.
reaction ever. Yeah.
Yep. Yep.
So-
And for me, we're entering spring. And the thing that I always have to remind myself is this feeling that I have where my eyes are red and my head feels woolly and my nose, it's allergies. Fraser, you have allergies. You don't fight it. Take your Claritin and move on. So I'm ready. I'm ready for when, here we are. The flowers are going to start to bloom shortly, and I'm ready to have to battle the allergies. So just keep that in mind, that that there are these cycles, and we are all a part of it.
It is true.
We have dust storms on Earth, and of course, the famous dust storms on Mars. There are even dust storms on Titan. What causes these storms, and how do they work differently on the worlds in the solar system? But what about the exoplanets? We'll talk about it in a second, but it's time for a break. And we're back. Have you ever been in a dust storm?
Yes.
I haven't. What happened?
It's just one of these things of, I need to be inside right now, as the air suddenly becomes thick and loud, and it's just not normal. You can actually see the storm coming.
Wow. Where were you?
Tucson. I've seen them
okay.
in Tucson, and it's just creepy. That's the best word I've got for it. Is you shouldn't be able to see eddies in the air, and you can with dust storms.
Wow. I guess, the closest I've ever seen is I saw dust devils
Oh, yeah.
when
They're
I was
cool.
driving across the U.S. and we were in a deserty part of eastern Washington, and I saw a bunch of dust devils, and that's a very tiny version, but you can get these sort of, like, as you say, these giant ones that are horizon to horizon and approaching you like a wall. That's crazy. So before we sort of get off of planet, what's going on? How can, like, there's winds all the time. How do you get this very specific kind of event that creates this giant dust storm?
It's a combination of having air that is the correct humidity, you need it to be dry, of having a storm front coming through over the dustiness. So once you get some particles levitated, they will start interacting with the surface, which levitates more. And it actually ends up being a lot of an electrostatic effect, which is why you need to have the dry air.
Right.
Sand is conductive at enough of a level that you end up with charge in the atmosphere, a deficit in the ground, and suspended particles that are just gross.
Right. And whipped up by the wind. And it's kind of amazing the impact that these dust storms have here on Earth. I mean, there's some really
Yes.
incredible pictures from Earth observing satellites where you can see these giant trails of dust leading off of Africa, making its way across to South America and probably depositing itself down in the forests there and delivering nutrients in some cases to places that are actually surprisingly nutrient starved, or dropping it in oceans and leading to plankton blooms. So there's a that dust actually has a pretty big impact on planet Earth.
Yeah, it can get suspended to higher altitudes than I had generally been thinking about until a few years ago. There was the massive dust plumes that coated Europe in layers of dust, where people in Spain were going outside and just like you could take it off of the windshield of your car and see it on your hand.
Right. That feels like what happened after Mount St. Helens blew. We were in Vancouver. We weren't like super close, but it rained dust. And so there was this dust layering on top of everything that you could absolutely, like snow, but it was made of rock.
And with volcanoes, it kind of makes sense because you literally have an explosive force sending the material high up into the atmosphere. The fact that wind can take dust from the surface and manage to keep lofting it higher and higher, the physics of that is just super cool, because it requires so many different things to be going on in terms of, you have to have this turbulence, you have to have the electrostatic forces as well. And it's that combination that allows it to loft higher and higher. And even just the collisions between the grains can make the grains smaller, which makes it easier for them to loft because it requires less force
Right.
to loft small things.
Right. Okay. Well, I think we're going to shift gears and talk about Mars in a second, but it is time for another break. And we're back. So while the dust storms on Earth can be incredible, they are still limited in scope and size, but something very different happens on Mars.
And this all comes down to the energy balance of our two worlds. Here on Earth, we have a mostly, but not quite, but mostly circular orbit that has the point in the year when we're closest to the sun is usually around January 5th. So it's not too different from the northern, sorry, cough medicine is killing my brain. It's not too different from the winter solstice. So we have the northern winter is made less drastic than the southern winter by this closest approach. The tilts of our planet are slightly different. The weather factors are slightly different, but it all adds up that we end up with some excess heat at the tropics. We end up with better regulation of cold. Generally, that's changing with climate change at the poles. No big deal. We have a slight energy imbalance across the seasons. We're fine. Now, with Mars, it's more than slight. Mars has a more elliptical orbit than we do. They're tilted more than we are. And it turns out that they are closest to the sun in their southern springtime. Now, this alignment of the seasons and the fact that it's the southern hemisphere, which is geologically radically different. It's the southern highlands. Mars' two hemispheres are radically different. There's lots of different explanations. It's fun to watch them compete. We're not going to worry about why.
Yeah. I mean, like I can think of like 5 times I've reported on different explanations for why the
Right.
Mars highlands are high compared to the other parts of the planet.
Whatever the reason is, this confluence of topography where it's the highlands of springtime and closest to the sun leads to an energy imbalance where they end up with a whole lot of excess energy in the southern hemisphere in the spring. And this imbalance in where the energy is can drive massive storms.
Right.
And what's wild is here on Earth, you have to be at a distance to see these storms coming up. The poor satellites going round and round Mars can only see a fraction of the disk at any given moment. Here on Earth, we can see the entirety of the disk. And there are amazing amateur images every time these storms come up,
Right.
that will show the storms coming away from the edge of Mars and see sections of Mars blurred out. Usually once some amateurs alert that this is going on, they'll get the Hubble Space Telescope pointed at Mars, and we can see these storms slowly erasing the entire face of the world as they start out sweeping across the southern hemisphere and will often go to engulf the entire atmosphere of the world.
And I know that one of the spacecraft that has been helpful for this is the Hope mission from United Arab Emirates. And they were able to take these whole disk images of Mars and have been charting changes in seasonal changes on the planet, and has been able to sort of watch some of these processes coming together as well. But as you say, it's sort of like one of those fields where amateurs are able to make a significant role because they've got the time to watch Mars all the time, while Hubble's got work to do. So, but I guess like sometimes you get these regional dust storms and then things settle down and the dust storm goes away. But other times the conditions are perfect and you get this full global dust storm where no part of the surface of Mars is visible. Do we know why one situation happens than the other?
It's looking more and more like it's when do the storms start. So it's just sort of like we have a hurricane season here on Earth where the difference between how hot the tropical weather is, the excess energy in the oceans allows these hurricanes to develop. Well, on Mars, it's that excess energy in the springtime is allowing these storms. So when you have storms occurring, when you don't have this energy imbalance, when you don't have the extremely hot land that is radiating, heating up the atmosphere at the junction between surface and atmosphere, without that excess heating, you don't have the energy necessary to generate the storms. So it all comes down to where is the energy. Here on Earth, they say for the economy, follow the money. When it comes to meteorology, follow the energy.
Right. So my story on this, or the story that we did on Universe Today, but this was my title, was when the weather is nice on Mars, you should panic.
Oh yeah, the clear air has a real part to do with it.
Yeah. Like you get warm weather, clear air, drier conditions. That heating effect is starting to take over, and it really feels like it's those periods of nice weather on Mars that actually drive more severe dust storms within a few months of when that nice weather started. And so I love this idea that, if there are people living on Mars at some point in the future, like, wow, the weather's been really nice. Oh no, here comes the dust storm.
And it's one of those things where here in winter, when the weather is perfectly clear, we know it's going to be a super cold day because the Earth is able to more effectively radiate away its heat. Cold days, you stay warm. Summer is the exact opposite. A crystal clear day in the summer means it's going to be super hot. Mars is the same thing going with those crystal clear days are the days that more energy is able to heat the surface. The more you heat the surface, the more energy imbalance you get, the more these storms can occur.
Yeah.
So, yeah, watch out. Clear skies in combination with the excess heating in spring will lead to global dust storms.
Lionel posted in the chat, clear sky morning, Martian take warning, which I love. So, I mean, and the effect of these dust storms, I mean, like, I think we all remember watching The Martian, where he is caught out in this dust storm and the wind is howling and hardware is being thrown around.
It was exaggerated. So the storms, they have winds that are 60 miles per hour, which is as a Midwesterner, it's like, oh, that's challenging, but not that bad.
In 1% atmospheric density.
And that's the thing. On Mars, they don't have nearly the atmospheric density we have. So while the extremely fine-grained dust is able to get lofted up, and then it also suspends due to it has the same static issues going on that we have here on Earth, even more so there. It's not that thick an atmosphere, so 60 miles per hour is just kind of cute. And
Yeah, you barely feel it.
Right.
You couldn't fly a kite in it.
Exactly.
But that dust gets everywhere, and that's
Yeah.
the challenge.
And it settles out of the atmosphere eventually. And it's the settling out of the atmosphere when the wind isn't gusting that's the problem. We found with the rovers that the wind gives and the wind takes. There are gusts that do good by clearing off the solar panels. When the wind stops and the dust just settles out of the atmosphere is when you have to really worry about how much energy are you no longer going to be able to get through your solar panels.
But we lost opportunity to a dust storm.
We did. So Opportunity was stuck in the sand. It wasn't at an opportune angle, but it was still functioning. They were still doing science with it. Then there was a global dust storm, and it shut down as far as it could, but it just didn't wake up on the other side.
Yeah, and I think that's the key is that the temperature is still cold, and this storm was cutting off almost all of its illumination, and so it was very, very dark. There's some great images that they show you the perspective that Opportunity had as the dust was causing its landscape to fade darker and darker and darker until it would have been just a useless environment for trying to draw power from solar panels. And also it was cold and it no longer had enough power to keep itself warm, and it couldn't recover when the dust storm had ended, which was very sad. But I mean, more than a decade of operation, which was fine. All right, we're going to talk about Titan in a second, but it's time for another break. And we're back. So I think most people would be surprised to hear that there are dust storms on Titan.
This is one that surprised me. We know from the images that there are dunes on Titan, so I guess it shouldn't be surprising that there are dust storms, but it just hadn't occurred to me, I guess. And this is the thing about science is the universe is far more creative than a lot of us are as human beings. And so here we have a world. It has a environment that's methane and ethane liquid instead of water liquid. It has clouds, it has rains and snow, we think. These are all the kinds of meteorology that can break down landscapes, create sands, transport them through. It has this super thick methane atmosphere. It has temperature variations, and where you have temperature variations in an atmosphere, you have wind.
Right.
And there are these amazing images that show shininess that isn't on the surface. It's only somewhat up in the atmosphere. It's not all the way up in the atmosphere. And they're able to figure this out based on how it moves in the images as the spacecraft and the moon both move. And so by figuring out how high up it was and how long it lasted, they were able to figure out that what they were looking at was actually a dust storm. So it appears that the grains that form those sand dunes, and this was occurring in the same region as of Titan, where they have the sand dunes. It appears that Titan, with its winds, can also loft sand into its atmosphere and have these dust storms.
But I think it's really important to make the distinction about what the terrain on Titan is like compared to the terrain on a place like Earth or Mars. On Titan, the ground is made of ice.
Yes.
The mountains are made of ice. The sand is made of ice. The sand dunes are made of ice. And so I guess the dust is made of ice with various hydrocarbon deposits mixed in with that are being lofted up into the atmosphere. So I just did an interview with somebody about Titan and how this world is like everything's shifted over. And then you can go to Pluto and you take it to the next level where now the atmosphere falls to the surface and becomes glaciers. But that's a future episode.
Yes.
So to think that this, even though you've got ice not rock, you still have very similar processes that are happening on the surface of this world, a place that seems so alien and yet so familiar.
And what's interesting is, since it's all cold, you end up with different physics. You don't have the same electrostatic forces building up between ice grains that are interacting, but you still have now, I guess it's more like thinking about snow getting lofted into the atmosphere. So imagine where the snow is getting lofted upwards, and the interactions between grains allow it to go higher and higher up until you end up with these clouds. It's whiteout conditions in a way, without having it falling out of the sky. It's literally falling up into the sky.
Right.
I guess falling is the wrong word.
Yeah. And then while with Mars, we talked about how the atmospheric pressure on Mars is 1% of what it is on Earth. On Titan, the atmospheric pressure is more than it is on Earth. And so high winds will have a completely different effect on you and on the sand and the dust around you.
And things didn't make it as high up into the atmosphere comparatively. One of the crazy things about Martian dust storms is they can actually get dust 100 kilometers into the atmosphere. So we're talking insane altitude of dust grains. And that's why it gets so dark, even though there's not that thick of an atmosphere, is you have kilometers upon kilometers of dust getting lofted up. So Titan, you have a thicker atmosphere, things aren't getting lofted as high.
That's really interesting. So I want to talk about exoplanets then. Do we have any evidence that there are dust storms on exoplanets?
So I wouldn't phrase it as dust storms, but if we talk about dust generally being either hydrocarbons, which is what we're seeing on Titan, or silicates, which is what we're seeing on Earth and Mars, we do see silicate clouds on hot Jupiters. So in these worlds, you have basically vaporized glass atmospheres, is one way to think about it. And at the junction between, for tidally locked worlds, at that junction between the night side and the day side along that terminus, you can get the formation of essentially nanoparticles of glass. So nanosilicate particles lofted through the atmosphere. We've seen this in JWST data of WASP-17. So there are sand particles forming in the atmosphere and snowing out. And quartz particles forming in the atmosphere and snowing out. And that's just wild to think about. And they're getting whipped around at extremely high velocities. These are not safe places to be, but they are amazing to imagine.
Yeah, and that is a mild hot Jupiter, that the really extreme ones are the ones where titanium and iron become ionized and become the atmosphere of these worlds, where it's so hot, the temperatures are thousands of degrees, the winds are, I think in one case, was it 30,000 kilometers per hour, like just ludicrous wind speeds. And so the closer you get to the star, the more you have this energy input and no way to get rid of it easily, the planet goes berserk.
And these are worlds that are not going to have the same life expectancy as Jupiter. They are streaming particles out behind them. They are getting destroyed by these stars.
But theoretically, we should eventually probably find similar conditions. If we have 3 places here in the solar system, that gives us good odds that we should find these out there around the universe.
Find what out there in the universe?
More dust storms.
Yes, we will continue to find more dust storms. We just haven't discovered them yet. We're still figuring out what to observe the atmospheres of. So far, it's easy to see the big things with lots of starlight passing through atmospheres. We'll eventually see the atmospheres of smaller worlds. We're just not there yet.
It feels like a thing that's possible, that dust gives off a certain signature, spectroscopic signature, and
it has
James
IR.
Webb is perfect for that kind of thing. Yeah.
Yeah, it re-emits extra light in the IR and has absorption bands, so that is detectable.
Yeah, and so you would think that eventually, if it turns out that M dwarf planets can support atmospheres, these may be the kinds of observations that we could make. You think about places like, there are these exoplanets that are thought to have lava plumes that are filling creating a cloud like
Yeah.
Io.
Yeah,
And
there was that discovery, I want to say a few months ago, where
yeah,
they believed that they detected the atmospheric signature of volcanic eruptions.
oh, right. And I think it was in the orbital disk
Yeah.
of the orbital plane of the planet that was leaving a trail, kind of in
Yeah.
the same way that Mars is thought to be that Mars dust is leaving a trail behind Mars as it goes, and is thought to be actually responsible for the zodiacal dust here in the solar system. So Zapfan mentioned that, and so I thought I would bring that back into the conversation. But yeah, it's amazing. I can't wait to the time when we can get more data points beyond just the three that we have here in the solar system. We actually can. Yeah, I'm ready. I'm ready to write that article.
We
Dust storm found on an exoplanet.
our life is going to be defined from coming of age as exoplanets were first discovered to hopefully being able to see either biosignatures or technosignatures at some point. It's really an amazing time to be alive.
Very cool. Thanks, Pamela.
Thank you, Fraser. And thank you so much to all the patrons out there that allow us to pay our editors to make us sound good. This week, we would like to thank Alex Rain, Andrew Poelstra, Antosaur, Astro Bob, Astro Sets, Benjamin Carrier, Benjamin Davies, Bill Smith, Bob Crail, BogieNet, Brenda, Brian Kilby, Bruce Amazine, Smansky, Claudia Mastriani, Cody Rose, David Rosetter, Diane Philippon, Don Mundus, Frodo Tenenba, Jeff McDonald Gold, Hal McKinney, Janelle, Jeremy Kerwin, Jim McGeehan, Jimmy Drake, Jordan Turner, Justin Proctor, Katie and Ulissa, Christian Magaholt, Mark Schneider, Michael Purcell, Michael Reagan, Nate Detweiler, Papa Hot Dog, Rando, Robert Hundell, Robert Plasma, Ryan Amory, The Air Major, Thomas Gazetta, Time Lord Iro, Will Hamilton, William Andrews. Thank you all so very much.
Thanks, everyone, and we will see you next week.
Bye-bye. And now I'm going to mute and cough.
Oh, you've been holding it back.
I failed to unmute when I thought I did. Yeah, the
they
entire last segment, I was just like, can't cough, must not cough, cannot cough. Okay.
Yeah, I've been there. All right, saved, uploaded. Hit us with your questions.
So this week we have a really interesting suite of launches. We have the
Spherex.
there's Spherex and Punch. There's also the Intuitive Machines and theoretically a Starship. So later this week, I'm probably going to do watch parties for a bunch of these. So I'll do that probably over on Twitch while I'm going through press releases. But yeah, lots of launches this week.
For people who don't know about Spherex, I don't know about Punch, but Spherex, it is a really interesting sort of wide field survey of the universe. Very similar in what is being done with, say, Euclid and Pierre Rubin and Nancy Grace Roman and the DESI survey. You're doing this wide scale, but it's looking for very specific kinds of molecules, things that are present in galaxies across the universe, and allowing us to understand concentrations of the universe, but also present in newly forming planetary systems. So it has this sort of dual purpose of helping us learn more about the large scale structure of the universe, as well as star formation and planetary formation. But what's Punch going to do? I
Punch
don't know
is
that.
a solar observer. It's going to be in low
Right.
Earth orbit. It has a polarimeter on it, so it's going to be looking using a polarimeter. You can see neat magnetic effects. It's looking at the chromosphere of the sun. So yeah, they're a rideshare. They are launching together. Punch is a small sat, so it's just a nice, tightly focused little mission. It is billed as doing 3D observations of the entire inner heliosphere to learn how the sun's corona becomes
Right.
the solar wind.
And then I don't know what the payload group is for intuitive machines, but
It's
you know,
changed multiple times.
with the last intuitive machines, that was the one that landed and fell over onto its side and was
Yeah.
able to send a plaintive beep beep home, but really wasn't able to fulfill its scientific objectives and wasn't able, delivered all of these instruments, but they weren't able to do their job. And so this is the return of intuitive machines. Hopefully this time they've learned the lessons from the first mission and they'll be able to stick the landing. But isn't it kind of crazy how just like still how difficult it's been to land on the surface of the moon?
And Blue Ghost is going in to try on Sunday.
Yeah,
So,
yeah.
so
got
we
some
have all
pictures of
these
the
launches and then all these launches rather, and then we have Blue Ghost going in for a landing.
Yep.
Yeah,
And
and
then there's the Japanese the second
iSpace.
iSpace.
It's
which is
going
gonna
in April.
Yep. And
And-
then go ahead.
And part of the reason that they keep falling over is they've been building them to these long, skinny fairings. So trying to fit them inside the cargo area naturally leads to a longer, skinnier weight distribution. When you have a higher center of mass, you fall over easier. So I think the key is they need to figure out how to adjust their center of mass, and we'll see. We'll see what has been learned with Blue Ghost.
Yes. Yes. But it'll be great. I mean, if they pull it off, that will be wonderful because that's a totally different company. That's Firefly Aerospace.
Yeah.
So you've got Intuitive Machines, you've got Firefly Aerospace, you've got iSpace, you've got what the Indians are doing with their missions. You've got hopefully we're going to get the second Bear Sheet lander making an attempt as well. So,
Yeah.
and then of course, all hopes will be riding on the upcoming Starship human landing system to demonstrate that it can deploy humans to the surface of the moon. The
Although
Chinese,
they're now talking about reversing and having Blue Origin's Blue Moon be what carries humans first. So that
I
is
haven't
getting
heard this.
discussed.
Is this new?
Yeah, that came out last week. It's a discussion. It's not definitive
Right.
yet.
Yeah.
So-
I wonder how certain CEO SpaceX executives feel about that.
Well, this is where the thing that came out a couple of days after that was a rumor that Artemis is going to get completely canceled with shifting all emphasis to going to Mars instead of to the moon.
Yeah.
So we don't know yet what is going to actually happen. Everything
Right.
is in flux. No one knows what's going to happen to NASA yet.
Yeah.
But-
I whined last week on my channel about how I still don't have anything to really officially report. But I do feel like we have one thing is that we know that there are budget cuts happening to many NASA programs, including James Webb. 20%? Is that right?
Well, and one of the things that happened was the Roses grant program, which funds significant amounts of science, all the different science mission directorates. It normally comes out on February 14th, thus the name Roses. It very briefly made an appearance on the NASA website Friday, I think, before getting yanked back down. So they aren't releasing information on what grants are going to be allowed for people to compete to. And the longer you delay announcing what grants are there, because there's a required 90 days between release of the announcement and deadline, you're now postponing and postponing and postponing when people can apply. So this is going to lead to funding gaps even for people who can be funded under the new,
Right.
whatever you want to call it.
So, and I know that an email went out to all NASA, all government employees,
Yeah.
telling them to justify their existence or fail to and effectively be terminated, which is and lawyers are telling the government employees to not respond to this message.
Yeah.
So we'll see what happens with that. Are there any other
So Congress
implications yet?
So the congressional subcommittee that handles NASA, a subset of that committee wrote a letter last week to the executive office, basically saying, no, sorry, they wrote it to NASA directly, saying that they hadn't gotten answers to the questions they had put forward about the conflicts of interest between Doge having access, not Doge having access to things within NASA, and Elon Musk having NASA contracts. They felt that that had been incorrectly answered. And they expressed concerns about the hiring process of the Doge agent, and that's actually the phrase NASA used, was Doge agent, who has been hired within NASA to report up to Doge.
So there's a person at NASA who is a Doge person. Okay.
And they weren't named, NASA didn't name them in the letter they sent to answer questions. So NASA is basically now being asked by Congress, what's up? We need more information. We're very worried about conflicts of interest.
Right.
So I think we're all just in a wait and see position.
Yeah. So still, I mean, I think last week we had this conversation that we're seeing carnage across the U.S. federal government, and a lot, when things like USAID being fed to the wood chipper and other such things.
Yeah.
But apart from NASA employees getting the, if you want to resign, now would be a good time email, and some of them taking them up on that.
Yeah.
We haven't seen these slashes and cuts and probationary employees being cut loose and directions being changed and hardware being canceled and missions being canceled. Like, we just haven't seen this yet.
Yeah. There was concern that education and public outreach on missions was going to get canceled last week, and we all breathed a sigh of relief that that didn't happen. That's especially allowing some activities around the launches this week. Yeah, we're all in a holding pattern. One piece of good thing, I don't know if I mentioned to you. So I was having this completely unrelated, going back to the blue ghost. I was trying to figure out why everything is blue this, blue that. And it turns out blue ghost is a kind of firefly.
Yes.
Okay. I just wanted to make sure everyone knew that, because I found that super endearing.
Yeah, totally. Yeah. Well, I don't see any questions. So you know what? I think I'm going to wrap up. We should wrap up the live stream now, because I'm going to want to fall asleep.
And I'm losing my voice.
Okay, we got one more question, and then
Okay.
Here we go. Samurai asks, Fraser, how is this looking for Canadian science funding? Does it look like we will follow suit, or we will double down on science and steal some talent while it's available? So I haven't heard any official thing. Like as Canadians, we're waiting for these tariffs to come through so that we know what is our official relationship to the United States. In theory, there's going to be 25% steel and aluminum tariffs starting on in early March, and threats of across the board tariffs, and also retaliatory tariffs if we respond to tariffs. So you could see this sort of vicious cycle as both countries are ramping up the tariffs. And the sad part right now is that American researchers are depending on Canadian researchers to publicize information about things like bird flu
Yeah.
and coronavirus and things like that, because we're if we're here in Canada, it's business as usual, and so we are continuing to publicly communicate what's going on with these various potential pandemic threats.
Yeah.
But that's all been removed from the United States. The CDC has been told not to do various levels of public awareness. And
Yeah.
I think that was said in the last administration. Like last time Trump was like, we wouldn't have all these cases if we just didn't check everybody. So I guess that's the plan this time around. And so I think that there is already and has always been, like, if you are a scientist in the United States, you have advanced degrees, you are relatively young, and you work in very specific industries, there's a fast track
Yeah.
to come and live and work in Canada to get your permanent residency, and then that takes you onto the path to citizenship. We have a it's like a test that you take where you get a certain number of points. If you can speak French, you get more points. If you have this level of degree, you get more points. And having it like a PhD, it's huge, as well as your age. How many more years of working capability can you offer to Canada?
Yeah.
And that, I think, for a lot of people, if they go and like take that quiz, you'll find you're a shoo-in for coming and living and working in Canada. And so I wouldn't be surprised if we see a lot of people applying to become come and live and work in Canada. The problem is that we don't have a lot of funding.
Right.
It's the same situation, that the actual science funding through the National Research Council is relatively limited. And so there's only so much money to go around for people to be able to do this work. And so I think if Canada really is smart, we will respond with enormous amounts of funding to take advantage of this misstep by the United States,
And you have
uses the
elections
chance.
soon.
Yeah, we do. Yeah, yeah, and that's unlike, and it's weird because the elections are. It is such a topsy turvy world from what it was 2 months ago. That
Yeah.
that the president of the United States declaring that my country shouldn't exist has
I'm
really
sorry.
focused. That's fine. It's fine. It's not your fault. Has really focused the will and solidarity of the Canadian people. And it's inspiring to see Canadians come together and be willing to tackle what had been very long-standing, slow-burning challenges. Like in the U.S., I know I said I wanted to leave early, but now I'm on a rant, so there you go. In the U.S., you can buy and sell goods in between the states, and it's easy to do. We don't have that in Canada. There are
Yeah.
interprovincial trade laws that make it harder in some cases for people in Nova Scotia to trade with people in British Columbia than for those provinces to trade with the United States or other countries. It's bonkers. And it's a way to kind of protect, especially Quebec. And so what you're seeing is just dramatic across the country willingness to drop those interprovincial trade barriers. You're seeing a real, it's causing this distinction to say, okay, the things that Canadians are, the things that we believe ourselves to be, we're going to double down on those things as a stark contrast to the direction that our neighbor is going. And I think that feels really good. And even like your political persuasion, whether you're a conservative or whether you're a liberal in Canada, that is now taking a far back seat to a series of shared priorities and vision for the future of Canada. And so I think that a lot of people, and I'm sure some Rye will agree with me, that it feels like it's scary because we're neighbors and we're dependent on the United States, and so much of our trade is dependent on the United States.
Yeah.
But it's also inspiring because we are finally coming together as a people to overcome what is a threat. So thank you for being the I guess the external threat to Canada. Pamela, you did it.
I hate everything.
That's fine. That's fine. So anyway, that's how we feel. And I think it's going to be interesting to sort of see how this all plays out. And my guess is that, 2 months ago, the election was a given. We were going to bring in a sort of similar right-wing response to decades of liberal power. And,
Yeah.
and now I think we're seeing something that's a lot more interesting and vibrant. So we'll see how it all plays out. All right, now I'm going to go and have a little nappy. So,
Okay.
thanks, Pamela, for bringing the brain. Thanks to Zapvan and Judd Suffield and the other moderators for hanging out and keeping everybody on the straight and narrow. What's the next big thing that people should keep an eye out for you?
So right now we're going to do an experiment over at CosmoQuest with, I'm going to be going through press releases, talking with the community, and working on developing our next set of citizen science projects on stream, basically to force myself to stream more. So I will be
Yes.
going live tomorrow at noon Eastern, going over press releases. And yeah, that's the next
cool.
big thing.
Wonderful. I've got a interview coming out in like an hour. I forget what it's about, but I recorded it. I'm sure it's interesting. And then QA, and then probably another interview, and then another QA, and then Space Bites. And I'm really got to do some telescope live streaming, and I've got to train you on the telescopes.
Yeah, I was going to say I
So,
need to learn
yeah.
how to use those telescopes.
Yeah. So let's hang out maybe some evening this week
Yeah.
and do some kind of
Let's
collab
look at the weather.
I got to do a collaborative stream. I got to bring in somebody else to also sort of expand the number of people that I can have on the stream. But also, we've now got the two telescopes. We've got the planetary scope and we've got the deep sky scope. So
Cool.
we'll do that as well. All right.